Hello viewers, welcome to CEC lectures. Myself Preeti Jagwani. I am from Department of Computer Science, Arbat College, University of Delhi. So in this series of lectures which is titled as Introduction to Programming Using C++, our today's topic is virtual base classes. So in the previous lectures we have seen the definition of inheritance, build a concept of inheritance, and then we have seen in detail the types of inheritance, and after the types of inheritance we have seen one common problem which occurs in inheritance quite often, which is diamond problem. So let's see what actually this diamond problem is in a quick nutshell in order to have a decent recap, and then we will talk about the solution of this diamond problem. So diamond problem, as the name indicates, it is kind of a structure of classes within the inheritance. It's a structure of classes which is forming a diamond shape. So what actually is happening? There are two classes, class 1 and class 2, which inherits the same base class, and both of these classes, class 1 and class 2, will in turn be inherited by one derived classes. So as the structure is shown on the screen, there are two classes 1 and 2 which are the derived classes of the base class, and there is a derived class which is the derived class of class 1 and class 2. So basically what is happening, whenever we are taking the derived class, it is creating two copies of the members of the base class. One copy of the members of the base class is coming through the class 1, another copy of the base class members is coming through class 2, and now derived class is having two copies of the similar member which is of the base class. So in some situations, in these types of situations, your compiler is going to throw an error and will not be able to take a decision that what is to be done in such cases. Now coming to the solution of the diamond problem, there can be two solutions to this diamond problem. One solution is you can use scope resolution operator, and another solution which is taking today's lecture is the virtual base classes. So basically two solutions to this ambiguous situation of diamond problem. One is scope resolution operator and another one is using the virtual base classes. So now let's try to explore both of these situations one by one. Now we have one base class, as we have already seen this example in our previous lecture, that we have a class, base class, in which within the definition of the base class we have an integer x which is of type public, just a simple data member of public type, and then we have class 1 and class 2. So class 1 is inheriting base class in the public mode, and it is having one of its own data members which is y, it is of type public. Similarly, class 2 is inheriting the base class in public mode, and it is having one data member of its own which is z. Now at this situation, if we can deep dive into the structure of class 1 and class 2. So class 1 is having one of its public member of its own which is y, and another member which is x, and that x has been taken from base class. Similarly, when we talk about class 2, this class 2 is having one of its own member which is z, and another member which is x taken from the base class. Now we have a derived class. This derived class is deriving two classes which are class 1 and class 2 in public mode, and it is having its own kind of, we can say, data member which is named as sum. So now this derived class, let's see the structure of this derived class, what all data members this derived class is having. So this derived class is having sum which is from own, which is of its own, then one member x, another member y, these two from the base class 1, one member x, another member y from the base class 2. So it is having two copies of x with one copy of y, one copy of z and one copy of sum. So we have seen that earlier this situation is kind of going to be very ambiguous whenever we try to access x. But now in order to incorporate a solution, what we are going to do, whenever we create, let's say we have created an object of the derived class and we have seen derived class one object obj, and rather than just saying obj dot x, the idea is to make it unambiguous. We will say obj dot class 1 scope resolution x. So basically what are we what do we mean here? We actually mean that we are referring to the copy of x which is coming to the derived class through class 1. We are not accessing the copy of x which is of the copy which is from the class 2. We have focused on one particular copy, and which copy we are referring to, that is very very clear when we use scope resolution operator. So this scope resolution operator double colon is actually being used before x, and rather than just writing obj dot x as we were writing earlier and compiler was throwing an error, we will say obj dot class underscore 1 scope resolution x equals to 10. So wherever we want to use x, we will be using it in the, we will be referring it in the same way. Obj dot y equals to 20 and obj dot z equals to 30. These two are very unambiguous statements because there are certainly only one copy of y and one copy of z. So these are not the ambiguous statement. It is not going to create any problem. Now whenever we are talking about again the sum, so we will say obj dot sum is equals to obj dot y plus obj dot z, no problem here. And while referring to x, we will refer it in the same way, that is obj dot class 1 scope resolution x, and then we are going to print the sum as obj dot sum. Now in the previous situation when we were not using scope resolution operator, compiler was confused because of the ambiguous statement of accessing the x without scope resolution operator. It was throwing an error. Now here in this program or in this main section, wherever we have used x, we have preceded it using an scope resolution operator, and we are also naming that which class copy we are referring to. So now the statement is unambiguous, and we will be having kind of our output, which is obviously here in it is 60. So whenever we are using scope resolution operator to specify which copy of x is to be used, we say obj dot class 1 x, or it could be obj dot class 2x. That means we are referring to that particular version of the x, either of class 1 or of class 2. So now no error is thrown as the ambiguous statement has been resolved to become unambiguous statement with the help of an scope resolution operator. So that's what the we can say one particular idea of how to remove the ambiguity which is arrived in the scenario of inheritance when we encounter diamond problem, or simply we can say what is the way of solving the diamond problem. So that the one way is scope resolution operator. Now what is happening here is Your scope resolution operator has removed the ambiguity. But actually what is happening? There are still two copies of the base class. One copy is with class 1, another copy is with class 2. So there are still two copies being created, but which particular copy we are accessing to, that has been that is now very clear with the help of scope resolution operator. Now just think, is there any need to create two copies of the similar class, of the same base class, one through class 1, another through class 2? That is, this double creation is actually undesirable, we can say. And now we should focus on what do we need to do that the only one copy of the base class will be created, and the another thing is that our diamond problem should also be solved. Scope resolution operator creates two copies of the base class, but that's being undesirable. We seriously don't want that. Now here comes the concept of virtual base classes, which is kind of, we can say, accessed, or which is implemented with the help of the keyword virtual. So we will be using this virtual keyword, where I am just telling you in some moments. The virtual keyword allows only one copy of the base class to be created, and the object of the derived class can access the members of the base class in the usual way. So derived class is going to use it the members of the base class without scope resolution operator, without any ambiguity, because only one copy of the base class will be created just with the help of use of this virtual keyword. Now where are we going to use and how are we going to use this virtual keyword, that we will see in a moment. Now in order to see the working of virtual keyword, we need to see this program. In this we have two statements. One is your standard hash include iostream and namespace standard. Now we are creating the upper level base class, because of which the ambiguities are arriving. That base class is actually, we can say, created in its usual way, but when this base class will be kind of inherited, that time there we will introduce the use of the virtual keyword. So here we have class, base class, and within the definition of base class we have public integer x. So that is the definition, class, base class, and within the public section we have integer x. So essentially no change in the definition or in the kind of syntax or structure of the base class. But when we are deriving, or when we are kind of, we can say, creating the class 1, which is inheriting the base class in the public mode or any mode for that matter, we need to specify the keyword virtual as shown on the screen, that class underscore 1, then colon, then there is virtual public is the visibility mode as we specify while inheritance, and then there is the base class. So this statement makes the compiler very clear that there can be multiple copies of this class, base class, but only one copy has to be created inside the derived class. There is no need to create multiple copies, which was actually done earlier. So by using this virtual keyword, we have prevented multiple copies of base class being created. So we have, I am just repeating the code once again, we have class 1 colon virtual is a keyword here. Public, you all are aware, it's a visibility mode. So virtual, public, and the class which you need to inherit. Here it is base class, and within the definition we have one normal data member which is of type public, and that is y. But this is not this only is not enough. While creating the class 2, which is also accessing base class, there also we need to use this virtual keyword as shown, that class 2 we have the colon thing, and then virtual public base class, and within the definition whatever you want to write, but we have used the standard definition, which is public standard definition in the sense which we have used earlier, that is just one member which is integer z into the in the public section. So now by using this virtual and keyword, we have made it clear that there will be only one copy of this base class. So even if we have one class which is class 3, and that class is also inheriting the base class, there also we will specify virtual visibility mode and base class whenever we create class 3. So it's not about only two classes, there can be multiple classes which are kind of using this base class, and it is desirable to have only one copy of the base class inside the next level derived class. So we will be using this virtual keyword. Now let's see what this virtual keyword is going to facilitate. Now coming to the definition of class, derived class. So the question which immediately comes into the mind, that is there any change in the definition of the or in the syntax of the derived class? No. So derived class is, whenever we are going to create this derived class, we will say class derived class, and it is inheriting class 1 in the public mode and class 2 in the public mode, or whatever visibility mode is there. Then within the definition section we have one sum as the member, one sum data member, and it is inside the public section. Now in the earlier solution which was using scope resolution operator, please recall that inside the main function we have, wherever we have used x, which is the member from the base class, we have used the scope resolution operator. So here, instead of a scope resolution operator to be used inside the main function, we have defined the base class as the virtual base class. So is it going to solve the problem? Definitely yes. How? Let's see. So inside the main, we will be creating an object of the derived class, which say derived class one object x, and now we can directly use obj.x equals to 10. It is just simply an unambiguous statement, just because of the use of the word virtual. So whenever we have derived base class into the class 1, we have used virtual public base class. Whenever we have derived the base class inside the class 2 or any other class for that matter, we will be using virtual visibility mode and the base class. So by using the keyword virtual, this statement obj.x equals to 10 is now unambiguous because of the simple reason that the keyword virtual ensures that only one copy of the base class has to be created, not the multiple copies, and as there is only one copy of the members of the base class which are being inherited, that means there is only one copy of this member x which is created, and simply we can use obj.x equals to 10, completely unambiguous. Obj.y equals to 20 was having no problem. Similarly, obj.z is equals to 30 was also very, very clear. Again, while using obj.sum is equals to, we will simply say obj.x plus obj.y plus obj.z. So either we can use that virtual keyword while inheriting the base class, or inside a main function we can use the scope resolution operator. Both the ways our diamond problem will be solved, but the only difference between these two ways is what using virtual keyword is, we can say it is more of a clean idea, or it's a better idea, because it is actually creating only a single copy of the base class, because while creation of the copies of the base class, the keyword virtual has been we can say specified. So compiler is aware of that only single copy of the base class has to be created. But whenever we are using scope resolution operator, at the time of creation of copies of the base class inside the inheritance, we have not specified anything. Within the main function, whenever we are using X, we are using the scope resolution operator, and hence we have not done anything in the situation when we were inheriting it. So obviously, multiple copies will be created. So that was the thing which was creating ambiguity. So we can use scope resolution operator, but then we will have to live with the multiple copies. And if we are desiring only one copy of the base class to be used, which is obviously a we can say a better idea in terms of memory, saving the memory and all that, we should go for the keyword virtual. Now till this point we have seen what actually the diamond problem is, and how can we can say prevent that diamond problem from happening, either by scope resolution operator or by virtual keyword. And we have seen both the solutions into quite detail. Now one thing which is very kind of relevant to inheritance, what we talk about is, do we really kind of allowed to make a private member inheritable? Can we inherit a member of a particular class which is in the private section, or which is the private members? So basically we can say in inheritance, when we talk about the private members of a base class, they cannot be inherited by the derived class. So what is the solution of this particular bottleneck? Now because the members of the base class, which are obviously under the private section, that's what I am talking about. So these members of the base class are not accessible to the objects of the derived class because they are private. So only the public and the protected members of are inherited and can be accessed by the derived class. So what if we need to make a private member inheritable? What could be the possible solution? So private members of the base class or any class can be made inheritable in two ways. One is we modify the visibility in their original class, obviously, from private to public. That means we need to make them public. And the second idea is making the access modifier of the private member public makes it inheritable by the derived class. So if we take the first idea, which is modifying the visibility mode from private to public, a problem arises with this approach that the data hiding property is no longer there for that members, because it is now accessible to all other functions of the program. Please remember, whenever we have a private member, it is not accessible to all other functions of the program outside the class, and hence we achieved the property of data hiding. And this was kind of a very initial concept when we started with the fundamentals of object oriented paradigm. So here, if we are going to change that member from private to public, that means now that member is public to all other functions of the program, but that was not the kind of requirement. the only requirement which we were focusing on, we need to make those private members as inheritable. So now the next situation comes up, which says modifying the visibility mode from private to protected. Can we, make the private members by turning them to protected? So what will happen if we, instead of having a private member, we have a protected member in its original class? This approach will retain the data hiding property of the private member, because a protected member will behave as a private member in its original class, also makes it inheritable and accessible by the derived class. So this is what we were looking for, that in the original class it should be private. That means it is not available to all other programs, all other functions of the program except the derived class. So that means we want to make it inheritable. So for that we need to change the access specifier from private to protected. This will make the member inheritable and accessible by the derived class by simply preserving its data hiding properties. So if these members are required to be inheritable further beyond the immediately derived class, then they should be inherited as public. Otherwise, they should be inherited as private, which will end the inheritance hierarchy beyond the immediately derived class. So if we want to make them open for the multiple level of classes, we can we can inherit them in public mode, and if we want to cut down the inheritance property after the immediately derived class, they should be inherited as private, and within the original base class they will be retained as private. They will be taken as private if we make them as protected, but now they are inheritable. So that is also something which we need to be very, very careful when we talk about inheritance. So in this lecture we have seen two things. One is what are the possible solutions of diamond problem using a scope resolution operator or using virtual base classes, and another is how to make your private members inheritable. And here is a list of references which is being used for preparation of the lecture. Hope you had a fruitful learning. Thank you.